Section 7.5, solving trig equations. We're going to start off with a simple equation. Solve the sine of x is equal to 3/4. Now, we've talked about something like this where to undo taking the sine of something, we need to use the sine inverse. So we can say that x is equal to the sine inverse of 3/4. And when we type this into your calculator, and we can do this in degrees, we can say that x is equal to 48.6 degrees. Now, this isn't the only solution, because remember, we're talking sine, so we have multiple quadrants where sine was positive, so now we need to find a quadrant 2 angle. So we need to take 180 minus our 48.6, and that will give us our second angle. That is 138.6 degrees. And those are the only two in our first lap around the circle that would give us a sine of 3/4. However, there's a whole bunch of other ones. There's an infinite number of solutions. What we have to say here is, and all angles, oops, let me spell angle correctly, G-L-E-S, coterminal with these. So this would kind of be the 360K portion of what we've done in the past. How we limit our answers is by using what's called principal values. Principal values are unique solutions of a trig equation if the values are restricted to two adjacent quadrants. Okay, so that's kind of a mouthful. Sometimes, when we've typed in our calculator sine is equal to negative something, and it gives us a negative 35 degrees, something like that, just an example. That's the calculator using principal values. So with principal values, let me just leave that there. Sine and tangent, we'll do this in red. Sine and tangent have the same quadrants for principal values. They are quadrants 1 and quadrant 4. If we're thinking in terms of angles or degrees, it would be negative 90, less than or equal to x, less than or equal to positive 90, and these are both degrees. If we're thinking in terms of radians, negative pi over 2, less than or equal to x, less than or equal to positive pi over 2. Okay, so when we're talking principal values and we're using sine and tangent, sine or tangent, we're staying in quadrant 1 and quadrant 4. With cosine, cosine uses a little bit different one. Cosine uses quadrant 1, and it also uses quadrant 2. Okay, so that would be 0 less than or equal to x less than or equal to 180 degrees, or in terms of pi, 0 less than or equal to x less than or equal to pi radians. Okay, so sine and tangent are the same, cosine is a little bit different. So what we can do is we can use this equation, use this idea to solve the equation for the principal values of x. Express your answers in degrees. So we're not going to be working in radians. I know you're going to love that. So we're going to stay in degrees. Now, how we're going to do this, and how I would recommend doing most of these equations, if not all, if possible, is by factoring. Going back to algebra 2 a little bit, factoring. Sine x cosine x minus 1/2 cosine x is equal to 0. Now, by factoring, what we want to do is we want to take out what both or all terms have in common, what they're both divisible by. And I hope you can see that both of these are divisible by the cosine. So if we take the cosine out of this, and I'm actually going to make this cosine of x, times, if I take the cosine out of both of these, what's left is going to be sine x minus 1/2. And it's equal to 0. Remember, when we're factoring, it has to be equal to 0 in order for us to be able to solve. If it's not equal to 0, then you'll have to move everything over to one side of the equation. So now that we've got it factored, we've got our equation factored, what we can do is we can actually set each factor equal to 0. This goes back to the zero product property. Cosine of x, it's a number. Sine of x minus a number also, or sine of x minus 1/2, that's also a number. We're taking one number times the second number, and our answer is 0, which means one of these two numbers must be equal to 0. So what we can do is we can split this off into two separate equations. We can say the cosine of x either needs to be 0, or the sine of x minus 1/2 needs to be equal to 0. Okay, well now we can just solve for x in each one. So for the first one, the one on the left, this one, all we need to do is take the cosine inverse. So we can say that x is equal to the cosine inverse of 0. And we're talking degrees. So what angle, and we're talking cosine, so now what angle between 0 and 180 would give you a cosine of 0? Well, you can type this in your calculator, make sure you're in degrees, and what you're going to find is that x is equal to 90 degrees. So there's one of your solutions. Now, For the sine, we need to get sine by itself first. So we can say sine of x is equal to 1/2, positive 1/2, and then we can do the sine inverse. So we can say x is equal to the sine inverse of 1/2. And let's see, sine inverse of 1/2, again, type that in your calculator. That should be 30 degrees. So we have two answers, 90 degrees and 30 degrees. Let's try a second one. 2 sine squared of x plus sine of x minus 1 equals 0. Now, it might help to think of this in terms of just a different variable. So off to this side, I'm going to just write replace sine of x with y. So really this becomes 2y squared plus y minus 1 equals 0. And this kind of really goes back into algebra 2. The number in front of x squared is not, or in this case y squared, is not 1. So we need to do the method of factor by grouping. And if you remember the factor by grouping, the first step is to take a times c. So we take 2 times -1, and that gives us -2. Step 2 in factor by grouping says we need to find two numbers that multiply together to get -2, but those same two numbers also have to add together to get the number in front, or the number in the middle, which is 1. Okay, so those two numbers are going to be 2 and -1. We actually were given those numbers already. We found them in step 1, kind of by accident. And then step 3 we need to use these two numbers, 2 and -1, to rewrite this term in the middle. So this is going to become 2y squared plus 2y minus 1y minus 1 equals 0. Okay, I'm just going from here down to here. Step number 4 in factor by grouping is to take our two terms, first two terms, last two terms, and we need to factor those. First two terms, 2y squared and 2y, both are divisible by 2y. And when I divide them both by 2y, that leaves me with y plus 1. 2y divided by 2y, 2y divided by 2y is 1. Get rid of those underlines. And then -y, -1, really nothing in common other than a -1. So we can say -1 and divide them both by -1 gives me positive y and positive 1 again. And if you remember, these parentheses have to match. And if they don't, you've done something wrong. But these do match, which is kind of helped by dividing the second group by -1. And then we can move on. Step number 5 says to write the product. So the one product comes from what's on the outside of the parentheses, 2y minus 1. The other factor in our product comes from what's on the inside, y plus 1. Okay? Now that we're factored, what we can do, we need to solve each factor again for, in this case, y. So we can say 2y minus 1 is equal to 0, and y plus 1 is equal to 0. Now solve for y. So the first one, the one on the left, we can say 2y is equal to 1, which means y is equal to 1/2. And then in the second one, we can say that y is equal to -1. Now, the problem with this is, my original equation was involved in x. And remember, we replaced sine of x with y. So what we can do now, and I'm going to do this in, we'll do this in blue, I'm going to replace my y's back with what they originally were, which was the sine of x. So we can say sine of x is equal to 1/2, and the sine of x is equal to -1. Again, these are things you can type in your calculator to figure out what x is. We can say x is equal to the sine inverse of 1/2, and x is equal to the sine inverse of -1. And when you type these two numbers into your calculator, what you're going to find is that x equals 30 degrees, or pi over 6 if you're thinking in radians, and x is equal to -90 degrees, which would be either -pi over 2 or 3 pi over 2 in radians. So just to quickly recap, factoring is going to be your best option here to solve these types of equations. If you can do it right away, that's great. Sometimes you might have to do some factor by grouping and some substitution in terms of just making things a little simpler, going from sine squared and sine to y squared and y, just to maybe make it more recognizable in terms of something you might have seen before. Sometimes, though, factoring won't work. And what we can do when factoring doesn't work is to use trig identities to rewrite the equation in terms of only one trig function. So in both of these examples here, well, this one not so much, we had two trig functions, but they were both divisible by cosine. This one, they were both one function already. This one, there's really nothing we can factor out of this equation to make it work like the very first one. So what we can do is we can rewrite, I would say rewrite sine squared of x in terms of cosine, so that it's all in terms of one trig function. Then we might be able to actually factor and solve. Okay, so what I'm going to do first, I'm going to rewrite sine squared as 1 minus cosine squared of x. That's one of the Pythagorean identities that we learned about in section 1, and the rest of it stays exactly the same. So it's still cosine squared of x minus cosine of x plus 1. Now, if we've got squared, we need this to be equal to 0. So what I'm going to do is I'm going to add cosine squared of x plus cosine squared of x. I'm also going to subtract 1, and let's simplify. These two on the right are gone, so this is equal to 0. 1 minus 1 is also gone, so that's taken care of. Cosine squared plus cosine squared is 2 cosine squared of x minus nothing to combine with the cosine of x, so it's there. Now, we could do factoring, but we don't necessarily have to because, when I say factor, I mean factor by grouping like we did with this example. We don't have to do that because we don't have that third term. Both 2 cosine squared and cosine are both divisible by the same thing. And that same thing, hopefully you can recognize, is cosine of x. So if I take a cosine of x out of this, I'm left with 2 cosine of x minus, let's see, cosine of x divided by cosine of x, that would be 1. And this is still equal to 0. So now we have it factored. Cosine of x times 2 cosine of x minus 1 is equal to 0. A number times a second number is 0, which means each of those two numbers could be 0. And we need to find an x value that makes each one 0. 2 cosine of x minus 1 equals 0. Okay? Simple algebra here and a little bit of trig. We can say that x is equal to the cosine inverse of 0. And we're going to find that x is equal to, let's see, with cosine we're in quadrant 1 and quadrant 2. And our answer here would be, let me just double check, we are in radians this time. So cosine inverse of 0, that's at 90 degrees, which is pi over 2. But if we go back and look, I just realized this, we're not looking for principal values this time. We're looking for everything that would have a cosine inverse of our answer or our number in the one full revolution. Now, cosine of the angle that has a cosine of 0, it is pi over 2, but if you look on the unit circle, you also have 3 pi over 2. Now, that's something where it's not, the calculator will not tell you that. You're just going to have to recognize that as we go along. Okay, let's try the second one here. 2 cosine of x is equal to positive 1, which means the cosine of x is equal to 1/2. Which means x is equal to the cosine inverse of 1/2. Okay, your calculator, if you do this in degrees, will tell you that the x value here is 60 degrees, which is pi over 3 in radians, but that's not the only angle that has a cosine of 1/2. So cosine was positive, and cosine is positive in quadrant 1 and quadrant 4, so we need to go pi over 3 radians into quadrant 4. So that would be 6 pi over 3 minus 1 pi over 3, and hopefully you can see that our second angle here is 5 pi over 3. So we actually have 4 answers for this original equation. Cosine squared of x minus cosine of x plus 1 is equal to the sine squared of x. We have 4 answers: pi over 2, 3 pi over 2, pi over 3, and 5 pi over 3. Let's try another one here. Let's clear that screen off just a little bit. Number 2 here. We're going to say cosine of x times the tangent of x is equal to 1/2. Now again, cosine x, tangent of x, it's one term. So what we need to do is we probably need to rewrite this using our identities. And I think it makes sense to rewrite tangent in terms of sine and cosine because we already have cosine here. So what we can say is that we can say the cosine of x, and I'll put it over 1 just because we know that the tangent of x is going to be equal to sine of x over cosine of x equals 1/2. And something really nice happens here. The cosine of x on the top in the first fraction, cosine of x on the bottom of the second fraction cancel each other out. So really what we're left with is sine of x is equal to 1/2. Okay, so from here we just have a single step remaining. We need to take the sine inverse of both sides. So we can say that x is equal to the sine inverse of 1/2. And if you type in sine inverse of 1/2, what you're going to find is that your x value, and again, we're still in radians, so that's going to be pi over 6. And if you remember the plus plus minus minus rule, the sign is positive in quadrants 1 and 2. So we need to go pi over 6 radians into quadrant 2. So we can say 6 pi over 6, because that's 1 pi, that's 180 degrees, minus our 1 pi over 6, so that would be 5 pi over 6. So our second solution here is 5 pi over 6. So 2 answers for this second equation. Final example is going to take me a couple of minutes to go through, but it is something that we can handle. Solve the equation for all real values of x. So we might have, all angles coterminal with these. We might have a k. I'm going to go with a k answer here, and we'll go from there. So solve the equation for all real values of x. 2 secant squared minus tangent to the fourth equals -1. So we're going to have a bit of a mess here. So let's just jump right into it. I think it makes sense to rewrite secant in terms of tangent, because our calculators can't do the secant inverse, but they can do the tangent inverse. So let's rewrite secant in terms of tangent. There was one really nice identity from the Pythagorean section in 7.1 that allows us to rewrite secant squared in terms of tangent squared, and that would be 2 times the secant squared is equal to 1 plus the tangent squared of x minus tangent to the fourth of x equals, and before we do that, I'm just going to move this 1 that direction, plus 1 equals 0. Because if we're going to factor this thing needs to be equal to 0. Okay, so let's distribute this. 2 plus 2 tangent squared of x minus tangent to the fourth of x plus 1 equals 0. This example is factorable, so let's just reorder things and combine some things. We can combine the 2 and the 1. I'm going to put the fourth power first, just thinking about standard form. Usually the biggest exponent comes first. So negative tangent to the fourth of x, positive 2 tangent squared of x, and then 2 plus 1 would give me 3 equals 0. Okay, so now what we want, we can factor this, but it's a whole lot easier to factor if our leading coefficient, the number in front of our highest exponent, is positive. So how I'm going to do that is essentially I'm going to divide everything here by -1. And just so you know, this is going to take a few lines of writing, so just kind of hang in there with me. So when I divide everything by -1, this is going to be positive tangent to the fourth of x minus 2 tangent squared of x minus 3, and 0 divided by -1 is still 0, so we don't have to worry about that end. Okay, so if you remember from Algebra 2, we have one of those factoring patterns was a 2-1-0 pattern, and we still have that here. It's just we have tangent. How this breaks down is normally if this was, let me say, if it was, x squared minus 2x minus 3, this would break down into x minus 3 times x plus 1. Well, the same kind of thing happens here. Notice that these two terms are the degree, the highest exponent of the term in the middle. Same thing happens here. So in case if this were to go to, x to the fourth plus or minus 2x squared, we still have that same pattern in the exponents. The only difference is now these are x squared minus 3 and x squared plus 1. So when we apply that same logic to these tangent problems, our two terms are going to be tangent squared of x and tangent squared of x. And the numbering system and figuring out the two numbers is exactly the same. Two numbers that multiply together to get -3, add together to get -2. Those two numbers are -3 and +1. So now we're factored. We can set each factor equal to 0. Let me slide this up a little bit. Let's switch to blue here. So we can say that the tangent squared of x minus 3 is equal to 0, or the tangent squared of x plus 1 is equal to 0. We need to solve both of these. The one on the left, tangent squared of x is equal to +3. I'm just going to get rid of that plus. +3. And then we need to square root both sides. We can say that the tangent of x is equal to the plus or minus square root of 3. And that one's solved. So now we can move to the other one. We can say tangent squared of x is equal to -1. And then we can say, let's see, we need tangent of x is equal to the square root of -1, which we have a problem there because we really can't take the square root of a negative number. It's an imaginary answer, and we're looking for real values. It says it right there in the directions, real values of x. So we've got our tangents separated and solved for. We can just say not real for this, so we really don't have to worry about the tangent of x is equal to the square root of -1. So now we can just split, let me switch to green here, we can split this equation off into two separate parts. We can say the tangent of x is equal to the positive square root of 3, and we can say the tangent of x is equal to negative square root of 3. Well, now we can find our x values. We can say x is equal to the tangent inverse of the square root of 3, and we can say the tangent inverse, or x is equal to, sorry, the tangent inverse of negative square root of 3, and we can find these using our calculator. Okay, tangent inverse of square root of 3, that tells me that the x value is 60 degrees. And remember, tangent, we're looking for all values. So we can look at the unit circle. Remember, with tangent, you can just go backwards. So when you get 60 degrees, we can go back towards the origin and follow it across the origin back into quadrant 3. And we'll find that that is also 240 degrees. That's a really bad degree symbol, 240 degrees. And we can do the same thing with tangent inverse of negative square root of 3. What we're going to find is that x is equal to negative 60 degrees, which would also be 300. Or if we follow that unit circle back across from quadrant 4 into quadrant 3, we would find 300 swings back around to 120, or you can think about it as negative 240. Just go back another 180 degrees, just like we're going forward 180 degrees for this. We can go back another 180 degrees to get these two. Okay, so we found our first few answers, but it's looking for all real answers. Let me go back and mark this. All real answers. So we've identified 4 of them, but how do we identify the rest of them? How we're going to do that is we're going to write 4 separate equations, or 4 separate answers, and we'll switch to we'll do this in brown. So we'll say x is equal to, we've got 60 degrees. We say x is equal to 240 degrees. We can say that x is equal to negative 60 degrees, and we can say that x is equal to negative 240 degrees. And what we need to say is, okay, yes, it's these 4, but it's everything coterminal with these. So what we're going to need to do is we're going to need to say 60 degrees plus 360k, where k is an integer, and we're going to do the same thing, 360k degrees, and we're going to do the same thing for all 3 of these, the rest of them, 360k degrees, where k is an integer, and then negative 60 degrees plus 360k degrees, where k is an integer, and then one more time, negative 240 degrees plus 360k degrees, where k is an integer. So if it ever says find all real values or all solutions, you're going to need to do something like this, where you're going to have 60 plus 360k. If it just says, find for everything between 0 and 2 pi, like these two did, that's something to keep in mind. If it says principal values, you're only going to have one solution. It's going to be one singular angle, and then that comes back to the principal values, depending on if it's sine, cosine, or tangent.